All right, let's dive into something we probably don't think about nearly enough, our kidneys. We're going deep on this one with The Body's Keepers, a social history of kidney failure and its treatments by Dr. Paul L. Kimmel.
And we're not just talking about the science here. This book dives into how medical discoveries around kidney failure really impacted people's lives, from everyday folks to, well, you'll be surprised who pops up later.
I'm intrigued. It's kind of wild when you think about it. Something as vital as our kidneys was basically a mystery for a huge chunk of human history. The book says before the mid-1800s, doctors couldn't even diagnose kidney disease.
Yeah, can you imagine? People were dying, and nobody knew why. It wasn't until the 19th century that doctors could even say, okay, these symptoms, they come from the kidneys. And even then, actually diagnosing someone was tough for a long time.
Yeah, like with Mozart, right. The book mentions his death in 1791 was probably from kidney failure, but they had no clue back then. Even Emily Dickinson, much later in the late 1800s, her diagnosis was still kind of a mystery.
Shows you how far we've come in terms of medicine. But that lack of knowing how to treat kidney failure, that went on for a long time. It wasn't until the 1970s that we really started seeing some breakthroughs. Buffalo Bill Cody, Sarah Bernhardt, Jean Harlow, even Cole Porter, the composer, all died from kidney failure.
It's heartbreaking, like even fame and money couldn't save you from this silent killer. So what changed? What finally sparked these big innovations in treatment that we have now?
Well, as awful as it was, World War II really pushed medical innovation forward. Think battlefield injuries, something called crush syndrome, basically. When your muscles are so damaged, they release toxins that overwhelm your kidneys. Doctors had to figure something out fast.
Desperate times, desperate measures, and that's where Willem Kolff comes in, this Dutch doctor who's like the ultimate wartime inventor. He basically creates the first working artificial kidney.
Talk about ingenuity. Picture this. He's using sausage casings, orange juice cans, everyday stuff to build these life-saving machines.
Seriously, orange juice cans. That's incredible. So how do we get from that to the dialysis machines we see today?
It was a process for sure. The first try at dialysis in the US, back in 1948. The book calls it a minor disaster. But here's the thing. It worked. They kept someone alive who would have died. From there, things evolved. New techniques like continuous hemofiltration came about, which was gentler for really sick patients.
Okay, so dialysis is starting to become a thing, but what about transplants? That seems way more complicated.
You're telling me, early attempts, there was a high chance the body would reject the organ, and the ways they were suppressing the immune system back then. Rough stuff, lots of side effects.
The ethics of it all must have been mind-boggling.
Oh, absolutely. You're the first successful transplant in 54. Huge deal, but it brings up so many questions. The fact that it was between identical twins made people really think about using living donors.
Which leads us to cyclosporine, right?
Cyclosporine, the game changer. Powerful immunosuppressant. And get this, it comes from a fungus.
Wait, what? A fungus helped make transplants more successful. That's wild.
Right. Nature always finds a way. But even with cyclosporine, risks remained and access to transplants was limited.
This is the 1960s, and dialysis, while possible, was crazy expensive. The book talks about doctors having to decide who got treatment and who didn't, based on if they could pay. There was even this life or death committee. Can you imagine?
The weight of those decisions, unimaginable. But that's what leads to a huge change. The US ESRD program in 1972. Part of Medicare, it gave every U.S. citizen the right to dialysis, regardless of whether they could afford it. Major impact, not just here, but around the world.
That's a landmark decision. But like a lot of policies, I'm guessing there were some unintended consequences too.
You said it. Millions got life-saving treatment, but the dialysis industry exploded. For-profit companies popped up left and right. And sadly, there are still big differences in who gets the best care, especially along racial and economic lines.
It just goes to show, even with amazing medical progress, you can't ignore the social and economic side of healthcare.
100%. And it's something we'll see again and again as we go deeper into this history. Take erythropoietin, or EPO, used to treat anemia in kidney patients. It's a perfect example of how complicated this all gets.
EPO. Before we get into that, could you explain quickly, what is anemia? Why is it such a big deal for people with kidney problems?
Sure thing. Anemia is basically when you don't have enough healthy red blood cells, the ones that carry oxygen around your body. Your kidneys, they help make a hormone called EPO, which tells your body to make more of those cells. So kidneys fail, you often get severely anemic. Fatigue, weakness, shortness of breath, the works.
Makes sense. And before EPO, what could they even do about that?
Frequent blood transfusions were about it. Sometimes life-saving, but risky in their own way. Iron overload, for one, which can mess up your heart and liver. Plus, it's not a permanent solution at all.
Right, like putting a Band-Aid on a much bigger problem. So
Yeah.
EPO comes along and it's a game changer, I'm guessing.
Oh yeah, total game changer. Being able to make synthetic EPO meant patients could produce their own red blood cells again. Huge difference for their quality of life, their overall health. But it wouldn't be a deep dive if there weren't a few twists and turns, right? As amazing as EPO was, it wasn't a perfect solution. This is where the biotech world comes in, with its own set of complications and corporate interests.
Right, the book talks about Amgen, the company that first made synthetic EPO. They were really pushing for higher doses, even when the evidence wasn't really there to support it.
Exactly. And that's where the Choir study comes in, this big clinical trial. It kind of threw a wrench in things. Turns out those higher doses of EPO that Amgen was pushing, they didn't actually help patients live longer. In fact, they might have even been harmful.
A good reminder that just because something is new and expensive doesn't mean it's better. Marketing hype can be powerful.
No kidding. It shows how important independent research is, really looking critically at new treatments, even when there's a lot of buzz around them.
Okay, so we've gone from not even being able to diagnose kidney disease to dialysis, transplants, even synthetic hormones. What a journey. Where do we go from here? What's next for kidney treatment?
Well, one area where we've seen huge progress is in genetics. For years, there was this mystery around kidney disease and Black patients. Certain types, like FSGS, were way more common in people of African descent, but nobody could figure out why.
So they knew there was a link, but they didn't know what was causing it. What were some of the theories back then?
Oh, there were plenty of theories floating around. But it wasn't until 2010 that researchers found the answer: the APO1 gene.
Okay, the APOL1 gene. Break that down for me. What is it, and how does it relate to kidney disease?
So this gene, it's part of our immune system. Specifically, it helps us fight off certain parasites. Here's where it gets interesting. There are some versions of this APL1 gene that are more common in people of African descent. And these versions, they seem to protect against a type of African sleeping sickness.
Hold on. You're saying this gene that's supposed to protect you from one disease can actually make you more likely to get another one? That seems a bit unfair.
Yeah, it's a prime example of how tricky genetics can be. Think about it. Way back when, these populations were dealing with this deadly sleeping sickness. The people with these APO1 variants, they were more likely to survive. So, over time, those variants became more common in those populations.
Wow, survival of the fittest in action. But how does this gene variant actually damage the kidneys?
It's still being studied, but here's what we know so far. These specific APO1 variants can actually harm the filters in your kidneys, the parts that clean your blood. Over time, this damage leads to inflammation, scarring, and eventually kidney failure.
So discovering the APOL1 gene was a major turning point, right? It finally gave an answer to why these kidney diseases were so prevalent in Black patients.
Absolutely. It was huge, not just for science, but for understanding and addressing these health disparities. And this discovery has opened up all sorts of new possibilities for treatment.
Like what are researchers working on now that they have this genetic piece of the puzzle?
Well, for one, they're trying to develop treatments that specifically target those harmful APO1 variants, blocking their effects.
That sounds promising. Anything else in the works?
Oh yeah, there's a lot happening. One area I find particularly fascinating is xenotransplantation.
Xeno what now? That sounds intense.
I know, right? Basically, it's using organs from animals for human transplants. And when it comes to kidneys, the animal of choice is, you ready for this? The pig.
Wait, pigs? Like farm animal pig?
The one and the same.
Yeah.
It might sound crazy, but the science behind it is pretty advanced. We can actually modify pig genes now to make their organs more compatible with the human immune system. They've even done successful transplants of pig kidneys into brain-dead humans already.
That's incredible. So could this be the answer to the organ shortage problem?
It has potential, for sure. But we're not quite there yet. There's still some big challenges. For one, the ethical and safety concerns are huge.
Right, we can't just start transplanting pig organs into everyone without thinking about the consequences.
Exactly. What if we accidentally give people animal viruses? That's a real concern. And then there are the bigger ethical questions. Is it okay to use animals this way? What are the long-term implications? It's complicated, to say the least.
It sounds like we're on the verge of some mind-blowing breakthroughs, but there are also some really weighty issues to consider.
That's the thing about this field. It's full of ethical gray areas, tough questions with no easy answers.
It really makes you think, about the future of all this. where do we go from here? What are the big questions we need to be asking, not just about the science, but about the ethics, the societal impact, all of it?
Well, I think it's important to remember that finding a cure, well, obviously the goal isn't the only answer. We can do a lot to make existing treatments better, less disruptive to people's lives.
So for people on dialysis, what would that even look like? I mean, is it more user-friendly technology, fewer treatments?
Those are definitely part of it. And for transplant recipients, there's a ton of research going into new immunosuppressant drugs that are more targeted, fewer side effects.
Oh, and we can't forget about preventing kidney disease in the first place. Seems like that's always the best approach, right?
You're preaching to the choir here. We know diabetes and high blood pressure are huge risk factors for kidney failure.
Yeah.
Catching those early, managing them well, that's crucial to preventing damage down the road.
So it's like a three-pronged attack. Find a cure, improve what we've got, and stop it from happening in the first place. But like we've been talking about, it's not just about medical advancements, right? There's this whole other layer of social and economic factors that we have to address.
100%. Kidney health isn't just on the individual. It's a societal thing. Access to health care, having healthy food options, even just awareness of the risks, it all matters.
It's a lot, but this deep dive has been incredible. I mean, we've gone from ancient theories about pee to gene therapies and pig organs. If you had to pick one thing for our listener to take away from all this, what would it be?
Honestly, what gets me every time is just how resilient people are. The doctors and scientists who pioneered dialysis and transplants, the patients who face such tough odds with such strength, it's inspiring.
I love that. No matter what your diagnosis is, there's always hope.
Always. And knowledge is power, right? The more you understand this history, the wins, the losses, the work that's still being done, the better equipped you are to advocate for yourself, for better care for everyone.
So, whether kidney disease affects you directly or you're just curious about it, keep asking those questions, keep learning, and don't be afraid to speak up.
Couldn't have said it better myself. The search for better treatments, a better future for everyone dealing with kidney disease, it continues. And we all have a part to play in that.
This has been an incredible deep dive. Until next time, keep exploring, keep those questions coming, and keep the conversation going.